Hi students! Today we're going to be looking at arithmetic, sequences, and series. Beginning with an arithmetic sequence, what it is, it's formed by adding a constant to the previous term called the common difference. Use the variable d. This means every arithmetic sequence will be linear. Now that's the key to today's lesson. Every sequence and series we look at today will be linear, making it nice and easy to figure out the pattern and to figure out the explicit and recursive rules for them as well. So every arithmetic sequence and series will be linear. Determine if the following sequences are arithmetic. If so, find the common difference and the next term. Piece of cake. So we look at the first one here. I've got -10 to -4, -4 to 2. I've got a difference of 6. And then I've got a difference of 6. And guess what? Difference of 6, difference of 6. That means it is arithmetic. Yes, it is arithmetic. And the common difference is positive 6. In other words, the slope would be 6. Then it says, if so, find the common difference in the next term. So let's just continue the pattern. If I add another 6, my common difference is 6. My next term will be 20. So next term is 20. All right, so let's take a look at the next one. The next one, -2, -5, -11, -20, -32. Well, I am, what? Subtracting 3. And then I'm subtracting 6, and then I'm subtracting 9. Now this is most certainly not a common difference, so I would say not arithmetic. In other words, it will not be linear if I were to plot those points, so that is not an arithmetic sequence. Let's zoom in a little bit. There we go. All right. Now, of course, formulas. In this chapter, there are quite a few formulas. You don't have to memorize them though because, well, you don't have to memorize all of them, I should say, because a lot of them in this lesson in particular are pretty much just common sense. So for example, if you look at a recursive formula, we've talked about this before. Recursive formula is when you call the previous term. In other words, when you define a recursive formula, you always define your starting point. A sub 1 is blank. And then a sub n, every other term in the sequence, would be defined as the previous term. Again, this a sub n minus 1 is the previous term. And then the plus d is, of course, the common difference. So again, since this is just linear, you're going to be finding the slope, which would be your common difference, and then you would be calling your previous term and adding on that common difference. You could be subtracting it if it were negative. So that's going to be your recursive formula. Your explicit formula, however, though, is this. So you've got a sub n equals a sub 1 plus n minus 1 times d. Now it also says below you can just use the slope-intercept form of a line. Now again, you don't have to memorize this. However, there will be a good use for it. So you can memorize it if you want. You don't have to, but I will be using it later on in the lesson. If you don't want to explicitly memorize this, that's fine, but we also have this form down below. If you look at this, it should seem familiar because that is slope-intercept form. A sub 0 would be your y-intercept, d would be your slope, and n would be, of course, your x, your input. A sub n is your output. So again, we'll come back to this formula, but I'll refer back to it later on when I actually use it in the lesson. Find the recursive and explicit formula for the following sequences, then find the 12th term. All right, so let's begin. First thing I look at is what is my common difference? Well, common difference in this case is minus 6. Minus 6, minus 6, minus 6. Common difference, d equals -6. All right, so now what I'm going to do is write my recursive formula. I'm going to write both for this, so I've got the recursive formula and the explicit formula. Recursive formula, I start off with defining my first term. A sub 1 is 20. And then again, the pattern, a sub n, any other term in the sequence, I take the previous term and what am I doing? I'm subtracting 6. So this would be my recursive formula. So that's my recursive formula. Define the first term and then call the previous term, subtracting 6 in this case. So that's recursive. Now explicit, again, I'm going to use slope-intercept form. Now slope-intercept form again was a sub n equals my slope, which is the common difference in this case, my input, which is n, and the y-intercept, a sub 0. Well, if I look at this, I don't know a sub 0, but I can easily find it by, again, just continuing the pattern. So a sub 0 would be 26. That's right. I've got a sub n equals my common difference we decided was -6. So -6n plus 26. This would be my explicit rule. Explicit rule. So I've got my recursive rule over here, I've got my explicit rule right there. Now the reason why I need the explicit rule is, again, to find the 12th term. With the recursive rule, I can't necessarily just plug in to find the 12th term, but with the explicit I can. So to find the 12th term, a sub 12, I'm going to plug in 12 for n. So I've got -6 times 12 plus 26. So -6 times 12, -6 times 12, and then plus 26 comes out to be -46. Therefore, a sub 12 equals -46. All right, so go ahead and you can, go ahead and see if you can figure out the recursive, explicit, and 12th term for this next sequence. Pause the video and go for it. All right, so let's see if you got it. The recursive rule for this came out to be a sub 1 equals 9.2, and then every term was a sub n minus 1, and then minus 0.05. Common difference in this case is -0.05. So this is my recursive rule. Let's find the explicit rule. A sub n equals -0.05 times n. My y-intercept came out to be 9.25, and that was the explicit rule. A sub 12 for this one came out to be 8.65. Hopefully you guys solved that out correctly. All right, let's continue. There's that word algebraically. Now, a couple of you guys on that quiz did not show algebraic work. I want to see algebraic work because, after all, this is Algebra 2. So I want to see algebraic work on your paper. Now, if you look at this, I've got the first term. I've got the first term, second term, third term, fourth term, fifth term, and sixth term. I've got the first term and the sixth term. So I'm going to refer back to that formula I showed you guys on the previous slide, not the previous slide, but a couple slides ago, and that formula was this. It was a sub n equals a sub 1 plus n minus 1 times the common difference. I want to point something out to you guys here. This n, this subscript right here, is this variable right here. This subscript right here is that. So what I'm going to do is I can also use this for any two terms in the sequence. Down below, if you look here, I've got the 8th term and the 14th term. I can use the 14th term right there and the 8th term right here. You can use any two terms in the sequence for this formula. You don't need to know the first term. Now for these first two examples, I do have the first term, so I can just use it as it is. But on these two examples down below, we will adapt this to use any two terms in the sequence. It does not have to be the first term that I use. But right here, I am going to use the first term. So I've got a sub n. In this case, I'm going to use the sixth term. So a sub n is 15. 15 equals 17 plus, again, I'm using the sixth term and the first term. So 6 minus 1 times the common difference. In other words, there's going to be 5 common differences between these. 1 common difference, 2 common differences, 3 common differences, 4 common differences, 5 common differences. So I've got 15 equals 17 plus those 5 common differences. and I'm going to solve for D. So when I solve this out, I get -2 equals 5D, and when I divide by 5, I get D equals -2/5. My common difference came out to be -2/5 for this first sequence. So what I'm going to do now is write the explicit rule. Write the explicit rule for that. So I've got A sub n equals A sub 1, which we decided was 17, so I'm just going back to this formula up top here. I've got 17 and then plus n minus 1 times the common difference, which I just figured out was -2/5. So there's my explicit rule. Now, again, on the quiz, some of you guys did not simplify this. I always want to simplify this. So I'm going to go ahead and simplify this out. Let's see what I get. I get A sub n equals 17. Let's distribute that -2/5 through. So -2/5 n and then +2/5. Well, if I want to change these all to fifths, I don't know, I want to change it all to fifths. No, I guess I don't have to. So I'll get A sub n equals -2/5 n plus 17 and 2/5, or 17 times 5 plus 2 over 5. So you can keep it as a mixed number. Improper fraction doesn't make a difference. This is the explicit rule. Once I have the explicit rule for this, all I need to do is plug in the term numbers that I'm missing. So I'm going to go ahead and plug in 2, in for n. I'll plug in 3, in for n. I'll plug in 4, in for n, and 5, in for n, and I'll come up with those missing terms. They come out to be 16.6 and 16.2 and 15.8 and 15.4. Now again, I showed algebraic work. I want you guys to show this algebraic work. Could you have figured this one out without using algebraic work? I know you could have. However, again, since I'm testing you on your algebra skills, it's not just a matter of can you figure out the pattern and then find the missing terms. I want to see the algebraic work. So if this were a test or quiz question, I will be looking at your papers to see if this is on there. All right, so let's continue on. That was the first one. I want you guys to go ahead and pause the video and try to figure out the second set of missing numbers here. Make sure you show your algebraic work. Go ahead, pause the video, and check it out. All right, so the second one here, the next one, I've got missing terms, -17.25. I've got -16.5. And I've got -15.75. The common difference in that case came out to be 3/4. 3/4. Again, make sure you're showing that algebraic work. All right, so the next one I'm going to continue on to, we've got find the 205th term of the arithmetic sequence with A sub 8 being 85 and A sub 14 equals 157. Now again, I want to show you how you can adapt this to accommodate that you're not given the first term. You don't need the first term. Instead of using this formula, I'm just going to change it a little bit, and I'm going to say A sub n equals A sub m plus n minus m times the common difference. Now again, all I've done here, instead of using the first term, I'm using any two terms in the sequence. This n, A sub n, will be a term further down in the line. In this case, it would be the A sub 14. A sub n will be an earlier term in the sequence. And you can think about it because I'm going in alphabetical order. A sub m would come before A sub n. Same formula, but I'm just adapting it so I don't need the first term. So let's go ahead and find the common difference. A sub n in this case is 157. A sub m would be 85 plus, and then I've got 14 minus 8. Those are my term numbers, 14 and 8, times the common difference, D. Don't know the common difference yet, though. That's what I'm trying to solve for right here. So let's go ahead and solve this out. I have 157 equals 85 plus 6D. So 157 minus 85 is 72. Therefore, 6D equals 72, and D, the common difference, is therefore 12. Where am I going with this? Well, I wanted to find my common difference so I could write the explicit formula. If my common difference is 12, let's go ahead and, do I need to do that? No, I don't need to do that actually. All right, I don't need to find the explicit rule. Watch what I'm gonna do next. I've got the common difference is 12. So what I'm going to do is I'm now going to take what I'm solving for, the 205th term, and I can choose either one of these. Let's go ahead and choose the 157 here. So I'm going to go ahead and go back to this formula again, the a sub n equals a sub m plus n minus m times d, and I'm going to now solve for the 205th term. So a of 205, or a sub 205, equals a sub m. I'm going to choose this 157, and then plus my two term numbers subtracted. Again, the two terms I'm using, now I'm finding the 205th term, and I'm using the 14th term. So plus 205 minus 14 times the common difference, which we just found to be 12. All right, so that goes right there. Sorry, I ran out of room there. So again, what I'm doing is I'm using this formula, I'm finding the 205th term, I'm using the 14th term in my sequence, so a sub 205 equals the 14th term, which is 157, plus my term number subtracted, 205 minus 14, times my common difference, which is 12. Let's see, so a sub 205 equals 157, I'm just going to do a couple quick calculations here, 157 plus 205 minus 14 times 12 comes out to be 2,449. So the 205th term in the sequence would be 2,449. Take a look back over my work and see if you can solve for the next term, or excuse me, on the next one. On the next one, you're finding the 111th term of the sequence where they give you the second term and the sixth term. So go ahead and follow the same process I did right up there, except you're going to be solving for the common difference and then finding the 111th term. Go ahead, pause the video and try it out. All right, so on this one, hopefully you guys got the answers correct. The answer was a sub 111 equals 1,175. And that was the solution for that example. All right, let's continue on. What's next? All right, we're going to switch gears. We just discussed arithmetic sequences. Again, a sequence is a list, a series is a sum. Now we're going to switch gears and talk about arithmetic series. And again, series is the sum of the sequence. So hopefully this looks correct to use this on your previous quiz. This is summation notation, also known as sigma notation. You've got the term numbers, 3 to 10. But notice this is the formula. Again, one error that quite a few of you guys made as you do sigma notation or summation notation, whatever you want to call it, make sure your variables match. On that quiz, some of you used a K down here and then you used an N in your formula. This and this should always match. So just make sure that does. All right, so we're going to be finding a partial sum. Now here's the thing. Again, on the quiz it said a partial sum. You're not finding the sum of the whole series. You're only finding part of it. In other words, terms 3 to 10, that's only part of it. That's called a partial sum. So anytime you're only finding part of the entire series, it's called a partial sum. This is the formula I'm going to be using, and the number of terms being added divided by 2, first term, and then the nth term. So let's go ahead and see if I can solve or evaluate for this summation notation. Here we go. Well, I need to find T1 and Tn, right? So I'm going to plug in 3 for n, and so T sub 3 would therefore equal 2 times 3 minus 1 is 5, and T of 10 would be 2 times 10 minus 1, so 19. So as I plug it into this formula, S of how many terms is that from 3 to 10? That's 8 terms. So the sum of the first 8 terms equals 8 divided by 2 times T sub 3, which is 5, plus T sub 10, which is 19. So 8 divided by 2, that's 4. 4 multiplied by, what is that, 24? Comes out to be, let's see, 696. So 96 would be the sum of the first 8 terms. Not the first 8 terms, rather, of those 8 terms, from terms 3 to 10. So that's how I'd calculate a partial sum. Again, it's literally just this formula. You do probably want to memorize this, though. This is probably one that wouldn't come naturally to you if you didn't memorize it. So find the indicated sum for the arithmetic series. This is, again, just a matter of plugging into that formula I just showed you guys. So let's go ahead and practice that. I've got S of 15 terms equals 15 divided by 2 times, and then I need to find my first term, and I need to find my 15th term. So T sub 1 would be, plug in 1 right there, I've got 7. And T sub 15 would be, plug in 15 right there, that would be 35. So I've got 7 plus 35, and when you solve it out, the sum of the first 15 terms comes out to be 315. Go ahead, pause the video, and see if you can find the sum for the second and third series. Oh, on this last one, you'll have to find what the pattern is first, of course. So go ahead, pause it, check it out, and we'll check your answers. All right, so the sum, how many terms is this? That is not 11, it's 12. So the sum of those 12 terms would be negative 1,680. And the sum of those 18 terms would be negative 1,449. Hopefully you guys are getting these correct. All right, let's continue. Now again, those were called partial sums because it wasn't the sum of the entire sequence. So when you're finding the sum of the entire sequence, that's actually a topic we'll discuss more next block with geometric sequences and series, but these are just partial sums. If you think about a linear sequence, you've got linear, right? It's either going to be increasing infinitely or decreasing infinitely. What would happen if you try and take the total sum for this arithmetic sequence? Well, think about limits. You've got a line, right? Your limit will be where? Positive infinity. If the line were going down this way, your limit would be negative infinity. When you try to take the total sum, not a partial sum, but when you try to take the total sum of the entire sequence, it's going to be infinite. You can't find the total sum because it's going to be infinite. If we want to calculate a total sum, it's got to converge. But arithmetic sequences always diverge. They don't have a limit, or in other words, the limit is infinity. So every arithmetic sequence and series will be divergent. It won't come to a single value. It'll just continue on to either positive infinity or negative infinity. But we'll, again, discuss that more in depth next block with our geometric sequences and series. All right, so let's look at a couple more examples. I think we're on the last two here. The center section of a concert hall has 15 seats in the first row and 2 additional seats in each subsequent row. How many seats are in the 20th row? All right, well, first of all, let's see what the pattern is. So I've got 15 seats in the first row, then every row after that has 2 additional seats. So 15 seats, 17 seats, 19 seats, 21 seats, so on and so forth. What is the common difference? 2. Common difference being 2. Let's go ahead and write the explicit rule for this. So a sub n, let's just use not point slope form, slope intercept form. So a sub n, slope would be 2 to n. The 0 term, or the y-intercept, would be 13, plus 13. Let's go ahead and then find how many seats are in the 20th row. We take the 20, plug it right there for n, and a sub 20 would be 53. And of course, so I wrote 50. And of course, answering in a complete sentence, I would say there are 53 seats in the 20th row. Don't forget your complete sentence. How many seats are there total in the first 20 rows? Pause the video and see if you guys can check this one out. Well, so for this one, we need to use the sum formula, right? That sum formula. S of n was n divided by 2, the first term, and the nth term. So in this case, I've got the sum of the first 20th rows. Well, luckily, we know that 20 divided by 2, I've got the first term, which up here was 15. And I know the 20th row has 53 seats in it, plus 53. So let's just calculate that real quick. 15 plus, what am I doing? 15 plus 53 is 68, times 10 is 680. So the sum of the 20 rows would be 680. 680 seats. I would say there are 680 seats in the first 20 rows. And there you go. All right, so one last example of the day, and then our lesson will be complete. And the last example it's a little bit tricky. So we've got the sum of 3 consecutive terms of an arithmetic sequence is -3. The product of these terms is 48. Algebraically determine the terms. Again, algebraically. If this were a quiz or test question, guess and check is not algebra. I want to see the algebra. All right, so let's go ahead and figure this one out. Now, I've got 3 unknowns. I've got 3 consecutive terms. I know that they're consecutive, so that's helpful. And I know that their sum is -3. And I know that their product is 48. So what I'm going to do is come up with a system of 3 equations to relate these 3 terms together. Again, since I have 3 unknowns, I need 3 equations. First things first, I'm going to say x plus y plus z equals -3. The sum of the 3 consecutive terms is -3. So their sum is -3. Then the next obvious one is the product of these terms is 48. X multiplied by y multiplied by z is 48. And then the last one that might not occur to you, but here it is I'm going to use the sum formula. Now again, they gave us that keyword sum. I'm going to use my sum formula. S equals, or in other words, -3 equals, because they told us the sum. -3 equals how many terms? 3 terms divided by 2 multiplied by the first term and the nth term. So I'm going to say x plus z, because I'm finding the sum of the 3 terms. So my first term in that piece would be x, and the last term would be z. Notice I'm skipping y because I'm just using the first term and then the nth term. So those are my 3 equations. Let me zoom in just a little bit. Continuing along, now from here, I've got to get it down to two variables, right? Because if you think about how we solved a system, what we did is we actually we eliminated one of the variables and then paired the two variable equations together. Now notice I've got x and z in this last equation, so that's going to be helpful for me. I'm going to go ahead and simplify this out a little bit because I don't really like the way that looks. So I'm going to simplify this out. Let's multiply both sides by 2/3, and I get negative 2 equals x plus z. So what I did is I just simplified this and I got this. From here, what I'm going to do is I'm going to go back up to this first, I'll call it equation number 1. So I'm going to go back up to equation number 1 and I'm going to plug in x plus z. X plus z is negative 2. So if I substitute in x plus z is negative 2, this is what I get. I get negative 2 plus y equals negative 3. And yep, you got it. Y is therefore what? Negative 1. So already we have one of our variables solved for. Now what I'm going to do next is I'm going to use this equation again, and I'm going to isolate, which I want to isolate. Let's isolate x. So I'm going to isolate x right here. I've got x equals negative 2 minus z. So x equals negative 2 minus z. Well, from here I've got x equals negative 2 minus z, and guess what? I also have y equals negative 1. So let me circle that and that. And from here, what I'm going to do is I'm going to use this second equation right there. I'll call it equation number 2 right there. I'm going to take y equals negative 1 and this and plug it into that second equation right there. And what's going to happen? What am I going to get? Well, if I plug into this equation, I'm plugging in negative 2 minus z. I've got negative 2 minus z multiplied by negative 1 multiplied by z equals 48. What I've just done is plugged in for x, plugged in for y. Now I've only got one variable left. So let's simplify this out a little bit. I've got 2 plus z times z equals 48. Therefore, z squared plus 2z equals 48. Therefore, z squared plus 2z minus 48 equals 0. And therefore, when I factor, let's see what I get. Z plus 8, z minus 6 equals 0. Z equals negative 8 and 6, or 6, I should say. Now, we're on the home stretch here. I just figured out that z could either be negative 8 or 6. I already know that y is equal to negative 1. So if those are my two possibilities for z, then if I plug this back in my product formula, when z equals negative 8, what's x going to be? Positive 6. And when z equals 6, what's x going to be? Negative 8. So what I'm going to do is just write out the two possibilities here. Z could either be negative 8 or negative 6. So therefore I've got my two possibilities being negative 8, negative 1, and 6. Or I could have 6, negative 1, and positive 8. And those could be the two possibilities for my three terms. And if you check again, they should work in all three equations. And that is the last question of the day. This is also very similar to a question in your homework. Make sure you guys are able to solve that one in your homework to get that quiz bonus. I'll see you soon. Bye-bye.